Okay, today we're going to learn about why do objects such as satellites, moons, and planets stay in orbit. So this has two learning targets, 26 and 27. 26, how are various bodies in our solar system similar or different? So you're going to learn about the planets, how the planets are different, what are meteors, asteroids, and comets, and how they're different. And the last thing we're going to look at is how to explain how investigating characteristics of various bodies in the solar system provides clues to Earth's origin and evolution. So we're going to talk about what about Earth and its position in the solar system, some of the characteristics about Earth allowed it to evolve and have life. Okay, so let's first look at the level of organization in our universe. So we have a universe which is a collection of galaxies. Galaxies are a collection of stars and planets. We are in what's called the Milky Way galaxy, and its shape is a spiral shape. And that's a picture of a spiral-shaped galaxy right there. Then we have galaxies are made up of stars and planets in solar systems. Okay, solar systems are inside galaxies, and solar systems are basically planets and other objects that revolve around either one star or more than one star. So that's the level of organization in our universe. You start off with the big universe. It's a collection of galaxies. Galaxies are collections of solar systems. Okay, and to give you an idea, there's different shapes of galaxies. A spiral shape, that's what the Milky Way is an example of a spiral-shaped galaxy, the one we live in. Okay, there are elliptical-shaped galaxies. That means they're very oval in shape. That's an example of an elliptic galaxy. Pretty cool. Irregular galaxies or cluster galaxies don't have any shape whatsoever, so we just call them irregular. Sometimes they're called cluster galaxies. And remember, these galaxies have a black hole at the center where all the other solar systems revolve. And here are some other pictures of galaxies. Kind of blurry. We've got elliptical, cluster, spiral. Okay, some other pictures. We've got two galaxies nearby. Okay, so we're going to start off talking about how the universe began. Well, that is the Big Bang Theory, not the TV series, okay? But basically, the Big Bang Theory states that a huge explosion created all the matter in our universe, the galaxy, the stars, the planets, etc. And I'm gonna show you two um, animations on that. So this one is the Big Bang Time Machine. So basically, we've got Earth, and we're going to go back to the Big Bang. Go. So we're going back in time to the Big Bang. Okay, see all the matter coming out of that explosion? That matter is what eventually created, there's some atoms that created our universe. Okay, now let's see if it'll take me back. Okay, oops. From the Big Bang, the explosion, there's all the matter in the universe. Now we're going back. Galaxy's going back. Okay. Okay, this is actually an animation. Okay, there's the Big Bang explosion.
Up until the 1920s, everyone thought the universe was essentially static and unchanging in time. Then it was discovered that the universe universe was expanding. Distant galaxies were moving away from us. This meant they must have been closer together in the past. If we extrapolate back, we find they must have all been on top of each other about 15 billion years ago. This was the Big Bang, the beginning of the universe. But was there anything before the Big Bang? We used to think that the theory of the universe could be divided into two parts. First, there were the laws like Maxwell.
Okay, so that gives you a short picture of kind of how the Big Bang might have looked like. What you see now is galaxies starting to form from the Big Bang, from all the matter coming together, and then planets and solar systems inside those galaxies. Okay, so based on the Big Bang Theory, scientists have come to accept the heliocentric model where Earth and other planets revolve around the sun. And that is accepted because of due to the force of the gravity that the sun exerts on everything around it. Because the sun contains 99% of mass in our solar system. So it therefore has the greatest gravitational pull. And that's why planets and other objects revolve around a star like our sun. Okay, so how, you might ask, did the planets form? Well, very similar as stars. There's a collection of dust and ice and gas that did not make up the star. So any of the matter that didn't make up the star, our sun, formed planets. So once we have enough matter that will start to contract into a spinning disk due to the force of gravity, we will get a planet. So then you get clumps of solids forming. These collisions combine to form planets. So that might have looked like something like this. So our solar system formed within a nebula, just like our sun, the remnants of a supernova. Remember we talked about that, how matter gets transmitted back into space from when a star is dying. So within that nebula, once the star is formed, then the rest of the matter near the star is going to coalesce into our planets. Okay, over billions of years, the spinning eddy created gravity that pulled particles together. These particles collided and they formed larger and larger bodies. These were called planetesimals and they became planets. The centermost region where gravity was the greatest became an incredibly dense, tremendous pressure from our sun that created our star. So it's kind of made, these are pictures that were created to see what it might have looked like when our solar system was forming. Okay, so that's how our planets formed, alongside with our sun. When our solar system formed, we have different types of planets. We have inner planets and outer planets. Inner planets are rocky and solid. The four inner planets are Mercury, Venus, Earth, and Mars. And you're actually going to do an activity where you talk about the characteristics of each planet, and we're going to read an article about that as well. The outer planets are larger. They're what we call the gas giants. They have a small solid core surrounded by a very thick atmosphere. And those are Jupiter, Saturn with the rings, Uranus, and Neptune that look very similar because they are both blue due to the methane in their atmosphere. One cool thing about Jupiter is it helps protect Earth from asteroids, and we're going to talk a little bit more about that later. Okay, so now let's talk about other objects that revolve around our sun besides planets. So you have asteroids. These are pieces of rock very similar to planet material, but they're smaller. We think they're left over from planet formation. So all the dust, ash, and gas that did not get put into a planet, those were left over as asteroids. We have a huge asteroid belt between Mars and Jupiter. So make sure you want to write that down. We also have another asteroid belt right past our solar system called the Kuiper belt. Okay, right outside of Neptune, we have another larger, much larger asteroid belt. And Pluto, being the dwarf planet that it is, actually goes past that or into the asteroid belt. Okay, next we're going to talk about meteoroids. Meteoroids are smaller than asteroids, and they're just small pieces of dust and rock. If a meteor hits Earth and burns up in our atmosphere because it's too small to make it to the Earth's surface, we call that a meteor. You've heard of it as meteor showers. Okay, and these are pictures of some meteor showers. If a meteoroid is big enough and it doesn't burn up all the way in the Earth's atmosphere and actually strikes Earth, we call that a meteorite. So you want to make sure you write down those three and know the difference between them. They're smaller than asteroids. Then we've got comets. Comets are usually bigger than meteoroids but smaller than asteroids. They are just dust and rock particles mixed with frozen water, methane, that's what NH4 is, and ammonia. Now, really neat thing about comets is when they orbit the sun, because they're smaller than asteroids, the sun's solar radiation actually strips the comet's matter away. And that's why a comet, you see it looks like it has a tail, because that's all the dust, ice, and gas that's being stripped away from the comet as it gets close to the sun's gravitational pull. And eventually the sun will strip most of the matter away from the comet, and that matter will have already been released out into space. Okay, so the last thing we're going to talk about is Earth's origin. And this is where it goes with target 27. Why did Earth evolve and have life and other planets didn't? So there is an article that's attached with these notes that you're going to want to make sure that you read. And it's going to talk about in more depth about other planets like Mars and Venus and why they may or may not have had life. Okay, so reason why Earth has life is because it has liquid water. We are a certain distance away from the sun where the solar radiation that we receive is enough for us to have liquid water here on Earth. We also have an atmosphere, so we're able to trap in heat. We're also able to keep a water cycle going so water doesn't just evaporate and leave or never come back down as liquid. And the reason why we have an atmosphere is because we have what's called a magnetic field. And that's what this picture is showing you right here. The sun's solar radiation, if we did not have a magnetic field, would strip a lot of our atmosphere away. That's what happened with Mars. Mars used to have a magnetic field, and the magnetic field is created by the outer core, which is a liquid layer. That liquid layer of magma that moves around is made up of charged ions. Those charged ions create a magnetic field. Mars, we believe, used to have one. However, Mars is a lot smaller planet than Earth, and so Mars cooled. And so their outer core, Mars' outer core, cooled and stopped moving, and therefore the magnetic field went away. At least that's what we think. So it Mars doesn't have much of an atmosphere because the solar radiation just strips the atmosphere, the gases right away from Mars. We have a magnetic field, so that protects us from a lot of that solar radiation. That's what this picture is showing right here. The scientist who discovered the magnetic field was Van Allen, and these are called, the magnetic field is actually the different bands of the magnetic field are called Van Allen belts. So the last thing we have as far as being able to have life is that we've had time to evolve. So Jupiter, I mentioned this earlier, is a large gas giant and it actually protects us. It's like a big brother from asteroids. Now, of course, Earth has been hit by asteroids, and we've had mass extinctions because of that. The dinosaurs 65 million years ago became extinct because of an asteroid impact. But Jupiter protects us from a lot of asteroids, and that has given us time to evolve. Okay, so what I want to make sure you do is after you've watched the video, go ahead and read our changing solar system. It should be attached with the notes. And I want you to read about how our solar system has changed, what happened to Venus and Mars. And it's just going to talk to you a little bit about some other characteristics that help create life and how other planets might possibly have life besides Earth. Okay, that concludes our notes for the day.